Hey guys, it's Ryan here behind the mic. Today is a special video and I'm going to be talking about 5 space phenomena that will probably explode your mind and make you insane. Just kidding, it's probably not. Let us start with TABBY'S star, also known as KIC 8462852. This crazy name is the name of a star, also known as TABBY'S star, 1,400 light years away. What's crazy about this star is the information we are getting about its light. Scientists and astronomers can detect the amount of light coming from a star, and a star should emit a fairly constant amount of light. And every so often, when a planet orbiting the star comes in between us and the star, the light dips because it blocks the light. But it only dips a little, because remember, stars are huge and planets are much smaller. For example, Jupiter moving between us and the Sun will decrease the light about 1%. Only a 1% decrease in light, and Jupiter is a huge planet, so keep that in mind. In this star system, we've detected a decrease in light of about 20% at a given time. If Jupiter makes a 1% decrease in light, what could possibly make a 20% decrease in light? Could it be a planet 20 times larger than Jupiter, orbiting that star? That's possible, but it's unlikely. If the object blocks 20% of TABBY'S starlight, it would have to be almost half the diameter of the star. That is enormous. But again, what could possibly be orbiting that star? One crazy theory is that there may be an alien megastructure surrounding the star, gaining its energy, kind of like solar panels. They may have a more advanced civilization than us, and are able to harness the star's energy up close. This is possible. Keep in mind, if there is an alien civilization at that star, it didn't happen right now. It happened 1,400 years ago, because it is 1,400 light years away. So yes, we are actually looking at the past whenever we see the data. Imagine what is happening now. Whatever the answer may be, whether it be a large planet, a weird anomaly, alien civilization, it'll probably be something new, something we've never really heard of before or didn't realize could happen. Next up, planets hotter than stars. Yes, you heard that right. There are planets out there that are hotter than most stars. A planet named Kelt 9b, for example, has a temperature of more than 4,300 degrees Celsius, or 7,800 degrees Fahrenheit. That's just a little cooler than our Sun. For a planet, that is insane. Now you would expect that this is a rocky planet, for it to be really dense and to attract all the heat, but it's not. It's actually Jupiter-like, and they're also known as hot Jupiter. Hot Jupiters don't really make any sense. We don't know why these Jupiter-like planets are so close to their star and how they are so high in temperatures while being a gas giant. It just doesn't really fit in with our thinking. We have theories and hypotheses, yes, but we are still very unsure. So there you have it. A planet is out there, hotter than most stars, orbiting its own star. Beautiful. On to the next one, the Great Attractor. The Great Attractor is a gravitational anomaly. You can think of it as a force pulling our galaxy in. But where is this force coming from? Since the beginning of space and time, the universe is expanding at an accelerating rate. So just imagine that all the galaxies that are floating in deep space are moving away from each other every day, faster and faster. Remember, this is happening to our galaxy even right now. Now the confusion starts when you realize that something outside our galaxy is causing us to slow down and even move in a different direction than we're supposed to be moving. Just as a side note, a cluster or a supercluster is a group of galaxies in space. Something scientists have realized is that not only our galaxy, but all galaxies in our supercluster are heading towards the Great Attractor. The Great Attractor has a mass of about 10 to the 15 suns. That is an insane number. It is pulling us towards it, but remember, it's moving away from us as well, due to the expansion of the universe, so don't really think that we're gonna collide with it anytime soon. What this Great Attractor is still unknown. Whatever it is a massive gravitational irregularity in deep space, pulling our galaxy and many others towards it. Absolutely crazy. Fermi bubbles is next on the list. Imagine the Milky Way galaxy. If we lie it flat down, eye level, it'll just look like a flat plane. And that's true. The Milky Way is flat. This is only true if we are seeing it with visible light. Now, what do I mean by that? Well, our eyes pick up stuff from visible light. If we switch over to gamma ray emissions, which we cannot see gamma rays with our eyes, if we switch over to gamma ray emissions, we won't just see the Milky Way galaxy flat on its side. We'll also see two enormous round structures meeting each other at the center of the galaxy. Each bubble, if we want to call it a bubble, rises about 23,000 light years above and below the plane of our galaxy. That is about 46,000 light years across the entire structure. How did these huge structures form? We don't know, but we know that they hint that a very powerful event happened millions of years ago. The theory goes that our supermassive black hole at the center of our galaxy consumed a very large amount of matter and then shot them out as huge bursts of gamma rays. This is definitely possible, but it's a theory. The exact story of how these bubbles formed is still a mystery that we have yet to solve. And finally, the Milky Way antimatter fountain. Okay, first of all, what is antimatter? Well, just as a very brief note, antimatter is the opposite of matter. Theories go that there was matter and antimatter at the beginning of space and time, and then matter, for some reason, seemed to take over. And so now we live in a universe that has mostly matter. Antimatter is like this. The nucleus of the atom is negatively charged, and the electron is actually positively charged. You see that it's the opposite of matter. And the electron on the antimatter is also known as a positron. And we can't really detect antimatter in space. But here's what we do know. We know that when matter and antimatter collide, they instantly annihilate each other and emit gamma rays. We can detect gamma rays in space, and if we see one out of nowhere, we can conclude that it was a collision of matter and antimatter particles. Now in 1997, astronomers detected antimatter blowing outwards from the center of our galaxy using the Oriented Scintillation Spectrometer. Specifically, about 15 billion tons of positrons per second were blowing outwards from the center of our galaxy. So what is causing all this antimatter to pour out? Again, don't ask me. That's the point of the video. Thanks so much for watching. With the holidays and Christmas coming up, be sure to get one of the limited edition Our Anatomy Astronomy shirts with your favorite planet on it. The link of the shop is in the description. Be sure to purchase one of these before time runs out, because then they will be gone forever. These are great gifts from me to you during the holidays, and I hope you'll be able to get one of these rare shirts in your hands. If you enjoyed this type of video, be sure to comment down. It supports me, and I will probably make more of these theoretical based videos, not much factual ones. And again, thank you guys for watching, and I will see you in my next video. Take it easy.